The subject of this afternoon's debate is the future of science, and with me are Professor Ewa Bartnik, biologist, biochemist, Warsaw University, Professor Jarek Grys, computer scientist, philosopher, York University, and Professor Karol Życzkowski, physicist, Jagiellonian University. My name is Łukasz Lamża. I'm a philosopher from Jagiellonian University, from here. And, well, the subject is broad, and beforehand we decided to split into manageable chunks. And I would like to begin with the question about the many roles of science, because science is a lot of things. Science is a way of learning the truth, so it's a method of knowing. It's a social institution, it's a way to make money, it's a lot of things. And my question is, let's think for a moment about science as an element of the structure of society. What does science do for society? And are you happy with the place that science currently has in society, about people's trust in science, with one eye to the future? I mean, are we happy with the situation that is right now? What would you like to see changed in the next 10, maybe 20 years?
If I may start, I'm very unhappy with the trust in science. I mean, there was a time when everyone thought that scientists sort of ran around with crazy eyes and sort of unfocused in general, very dissociated from normal life and did crazy things. I think this, to some extent, for reasons that I don't really understand, has remained with a lot of people. And the problem is, I mean, this is perhaps a stupid thing, but if you look at role models in journals, newspapers, and so on, it's generally businessmen and politicians. We are not role models. Unless someone gets a Nobel Prize, then for 2 days he's a role model, she is a role model, that is it. And the role in society, it's difficult. I think most change in how the world is not really perceived, but attacked or addressed is through science. I mean, with the very broad thing, we change by engineering, with chemical things, and I don't want to make lists. But I think the perception of science, and I'm not a philosopher, I'm a geneticist, is as something that's sort of there and unimportant. And I don't quite see how that could be changed, but I think it makes many things difficult, including getting young people to go into science.
You think that science has a low profile in society? That's what you mean? It's not famous enough?
I think it's more than that. I mean, the people who are famous nowadays are the ones who have blogs and Twitters and things like that, not institutions and things. It's more that I don't think people understand what science is doing for them.
Any comments?
Actually, can I go back a bit historically? I want to just give myself and everybody a bit of an explanation of why scientists are not as regarded by other people in society as they used to. So if you go back to the origin of the university, the current university, where we have scientists working at universities, that started in Prussia in 1810. The idea was that before that, scientists used to work in academies, which were usually funded by the state, and suddenly the Prussian government said, okay, let's put scientists into universities where they will teach students as they do research. This model worked quite well for the first, I would say, 100 years, where we had, thousands of students and hundreds of scientists. Because this was a very elitist enterprise. Universities were for the best of the best. 100 years later, in the 21st century, we have thousands times more students and as many more scientists. Well, what do you think happens when you make a certain profession massive? Well, the average quality of work is going to go down. And I think this is exactly what happened in science. Many people who go to work at universities are, I wouldn't say uninterested in doing science, but certainly very often not qualified. And I think this is, from my point of view, this is one of the reasons why the society does not have us in a very high regard, at least not in the regard they used to have us in the 19th and the first part of the 20th century. This is a massive change, I think. And the change is due just because we kept the model, which worked well at a small scale, but didn't scale up very well.
Excuse me, would you say that we don't need that many scientists? Would you agree to?
I would say so, yes.
Interesting.
I think that 10% of what we have now would be just fine.
Or even more. Karol Żyćkowski, physicist, theoretical physicist, in fact. Maybe you know that theoretical physicists are not known to be very, very modest, just on contrary. And sometimes we have a strange tendency to look from above for other scientists. Moreover, it's even worse, because scientists in general tend to look somehow down to other people, and they basically would like that the society pays them money, and they are well covered, and does not check what they are doing. And in a sense, this brings a larger and larger gap between our scientific community and the society. And therefore, we as scientists not always can understand what the people, let's say ordinary, in Polish you would say gray people are thinking, and just the opposite. Then the society does not care about science, about scientific discoveries, about this what we have to say.
I would agree with that, but just one thing, going back to the number of people in my field in the 60s, there was a group including Francis Crick, James Watson, people who got the Nobel Prize, who worked on one subject. It was all men, of course, and it was called the Lambda Tie Club because they all had ties with Lambda, and there were like 25 of them working on it. They all knew each other. I don't know. I mean, in my field, I worked on human diseases, mitochondria. I know maybe 25 people, but there are probably 3,000 or 4,000.
So can I continue with, just to give people an evidence why I think we have this quality of scientific research went down. Some people interpret this evidence in a different way, but let me just give it to you. So in March this year, Nature published a study done by Northwestern University where they asked the ChatGPT, the AI system, the very famous one, to write scientific abstracts for medical journals. And then they asked professional reviewers to look at them and try to identify the ones who were written by ChatGPT versus the ones that were written by actual humans. So they identified 68% of the ones written by ChatGPT, which you may think, well, that's a high number. But also they misidentified 11% of the ones written by humans. So this is one worry.
But only 11%.
Well, wait. So let me just continue. This is medical stuff. So you usually in medical article you need some data, real data. It's probably easy to catch if your data is not real. So the second study was published just today or yesterday, I think, in Finance Journal. They did very similar study. They asked the AI system to write now short paper, not an abstract, a short paper in finance, and they asked the reviewers again to they gave them a mix of papers written by ChatGPT and humans, and they asked them to rate them. From 1 to 10. The average for the one written by ChatGPT was 7.5, and they considered 5.5 to be acceptable for publication. So here's what the way people look at this is twofold. I mean, no, most of the people look at it in one way. ChatGPT is great. This is an amazing system that is able to write scientific papers.
Quasi-scientific.
Well, that's the second way of looking at it. The quality of work published in journals like that is so low, well, I shouldn't say that because some people actually may publish there, that it's not that difficult to match that. And that's what I started talking about, the model that I don't think is appropriate for massive education at universities and making research massive. It's not going to work. most of the people are not made for it, period.
And if I may, we will definitely come back to the issue of AI and all these, creative algorithms in a minute. But going back to the study you said, I will just briefly quote another interesting study that has nothing to do with these generative algorithms. That was the study of the average level of disruptiveness of scientific papers during the past 70 or 80 years, and disruptiveness was defined in various ways, but basically the idea was, on average, how much novelty, how much new ideas is in a given scientific paper, in a given discipline. And in all, there were 4 or 5 different measures of it, and 10 to 15 disciplines, and they all found the trend downwards. Basically, it says that there's more and more papers, about 3 or 4 million new papers every year, if I remember correctly. But they are less and less interesting. There's less and less new information in it. And when you told about this paper, I had a thought, well, we couldn't probably ask ChatGPT, please write a work that will revolutionize our understanding of reality, right? It's not able to do it, definitely. So what we need are those papers that will revolutionize our understanding of reality, not the million unimportant, repetitive, boring papers, right? So my question is, let's think about the future. How do you see it? Do you see it getting worse and worse? Or maybe ChatGPT will help with it? Because people will realize how bad science is.
People often don't have time to realize anything. I mean, I'm sorry. I mean, it has some advantages not to be very young, because I managed to get most of my scientific career done before I was forced to publish, before I was ready to. But the thing is that you don't anymore have the luxury of waiting for your results to be really something great. You have to publish a certain number of papers per year. You meaning the general scientists, because all the evaluations are based on what you produce. And I mean, you do have to produce. I mean, there's no use for science done by people who never have any output. But the balance is totally wrong, because the output is judged, and to a much lesser extent the quality of the science. I had coffee with a friend from Jagiellonian University today. She's on various European commissions and so on, and they are thinking of changing evaluation for sort of, how should I put it, essentially numerical things, how many papers, what impact factor and so on, to what does the science in those papers change in the scientific picture of things. Very, very difficult. It's much easier to add numbers.
So this would be a qualitative process.
Yeah, I think it's going back from the Marxists that quantity goes into quality.
So I think one more point about the model. So I think that we kept the model of science at the universities for so long because not because we think that so many people can do science. No. We kept it for that long because we have to have a way of evaluating the competence of people who teach students. So just think about it. Somebody is teaching a course on logic. How, in a, say, math department, how would his colleagues know whether he's competent in that area? The only way to test that competence is for him to publish papers in peer-reviewed journals where some other people who are competent in logic can look at it and say, yes, this guy knows what he's talking about. So we don't no longer, see, here's what I would like the administration of university, the society at large, to say out loud. We know that most of the people are not doing science. The papers they publish serve only one purpose, testing their competence in teaching. If we can openly say that, then we can say, okay, 90% of the people have to be tested as teachers, and only 10% will actually do real science. Why waste their time on publishing papers who nobody reads?
Just a minor remark. Even publishing a good paper in a good journal is not an evidence that you are a good teacher.
That's true, but it's an evidence that you're competent in your area.
Yes.
That's what I mean.
The problem is, I think I have always greatly objected. I mean, this is not about the future of science. This is more about teaching in university. From time to time, there have been extremely awful ideas of making academic and non-academic universities. So the ones where people do something in addition to teaching and the ones where people only teach. And for me, it's very difficult to evaluate the quality of teaching and no one does it properly. In addition, that's another matter. But the thing is, if I don't have any more insight than what I read from something into what I teach, why should I teach? I mean, they let them read the journals without my participation. So I have been always against the separation of science and teaching. Now, the way you put it is that we publish at universities so we can teach. But what would you do about the universities where nobody publishes anything and they teach?
I don't know. That's my. I just posed the problem. I'm not saying that I know the solution.
One minor remark. So another possibility to test is just to ask a person to give a lecture, open lecture, or in the faculty about his recent achievements. Then we will know what he is doing scientifically and also whether he is able to describe his results.
You think that the historian of Hegel will dare to say anything about the historian of Plato?
No, but concerning current results in quantum mechanics, if you are not able to describe what we are doing, it's already a sign that it's likely you are not a good teacher.
So perhaps it depends on the field.
Yeah.
I think there are fields where it's very hard.
But you know, honestly, do you have to be a world-class zoologist to teach a good course, introductory course in zoology? Do you have to,
Yes.
physics? Let's
Yes.
say we are talking about classical mechanics. Do you have to really be a scientist that creates new knowledge in classical mechanics to describe it to students very well?
You need something which I called VAT, value-added tax. You cannot teach something you just learned yourself. Someone who probably would have been 120 if he still lived, was a professor and the father of a friend of mine, used to say that if you have to prepare for a lecture, there's no reason why you should give it. Now, I don't quite buy that because there are too many things to remember. I mean, I know the idea, but I will not remember some facts that I have to present. But the thing is that I think unless you bring something more to it, and the more comes from the fact that you do science, and of course, then you'll ask, so how about high school teachers and so on? It's a slightly different thing. They don't teach how science is developing. That is actually another problem, because they teach science as something which is put, fixed, and has no problems whatsoever. This is high school. At university, it should be different. But perhaps, just perhaps, first-year course is very basic chemistry or biology. Perhaps you do not need to do research. But afterwards, you should never have undergraduate students unless you're doing research.
But I'm sorry, but this leads to the very problem that we're talking about. You know, millions of academic teachers who have no real innovation. They haven't really done anything innovative, but they have to publish so that someone will tick a box. Well, you can be a teacher. Okay, you have published. And doesn't matter, it's a very bad journal, it's a very bad paper, it has been half-generated by AI, it has repetitive data and it's bad, but okay, we require you to publish something once a year so that we are content and happy that you're going to be a good teacher. Isn't this the source of the problem?
I mean, I don't see a solution. The problem is that you have to teach. You have to teach reasonably well. And I have a pet bug also because the evaluation of teaching, I'm not saying now about the academic qualifications of the people who teach. There is no real evaluation of teaching. I was at the University of Warsaw for almost 50 years. And the evaluations of the way you teach are ridiculous. I mean, students fill in questionnaires where they will say that I am often late. I have never in my life been late to anything. So, and it's not only with me. And evaluations based on this, I mean, and your idea that someone gives a lecture, anyone can give one lecture if he prepares for it long enough.
One more remark. Of course, there are several people not teaching at all, like those working in Poland at the Academy of Science, in France or in Germany, in Max Planck Institute, and so on and so on. And still, they are then asked and even required to produce good scientific papers, but nowadays it's often the case, they only mimic, they pretend they do good science, and still, because there are so many of us, it's easy, well, it's difficult to check whether each of us does a reasonable job, and several of scientists only pretend that they are working.
It's just to give you an example of how things changed. I was a philosophy student in the 80s. There's this journal, Synthese, a Dutch journal. It used to be good.
It still exists.
Still exists. They used to publish about 100 papers per year. I checked a couple of weeks ago, 520 per year today. So you can imagine, can you ever read that many papers? It's a single journal. And it's probably there's 100 of them in philosophy. Who reads this stuff?
Well, according to statistics, nobody. I think about half papers or 60% papers are never cited by anybody. And then there's all the traditional laws of mathematics. Most of them are cited by one other paper, then by 2, by 3, by 4, by 5. And there's this tiny minority of papers that will be cited by more than 10 people.
Very skewed distribution, very skewed.
Very skewed, with 0, that's the important part. Yeah. 0 is at the... So I think everybody seems to agree that we have too much science, too much bad science, but I think the consequences of it are not palatable to us. I mean, if we wanted to divide all of the world's universities into the ones that are doing real groundbreaking research, and there are scientists who do excellent science, and they will publish 5 papers a year in biotechnology, and the rest are just doing teaching. Well, this would probably mean that no Polish university would do any science, likely.
But look, it's not fair to say that we divide universities into good, bad, or mediocre. Usually, it happens very often that there are very good people working at not very good universities, but you should not, let's say, average over the sample of entire university. Of course, it's rather fair to say that some scientists, few perhaps, maybe too few, are doing good or very good job. Maybe even majority or other part does not so well. But still, the distribution of those good scientists, okay, of course, in the, let's say, most known centers, like, I don't know, Cambridge, Oxford, Paris, or Munich, is more likely to find a world leader in one of second field than, unfortunately, in Krakow, Warsaw, Vilnius, or even Kielce and Radom, whatever. This is true. And unfortunately, in the panels of European Research Council, it is just such a perspective that if they really look for excellence, it's easier to find excellence in other places in the West. But it would be unfair to say that all people working at smaller places do not do good job. Maybe last example, I know a very, very brilliant physicist who, okay, has not got yet a Nobel Prize, but he still has some chances. And all his career, he worked at the, let's say, small college in eastern Massachusetts, I believe. And somehow, the fact that it was a small college, it was not an obstacle for him to produce great papers and really push quantum physics forward.
I think that let's go back to where we started. We started with the society mistrusting scientists, and we're trying to figure out what to do about this. And I think that unless we openly say there is science and there is something which we shouldn't call that, and there should be a way of differentiating between one and the other, then the average person will say, okay, this is a great scientist, he was called Einstein, and this is John Smith, and he's also a physicist, so he's a scientist as well. No, not necessarily. The fact that he works in physics doesn't make him Albert Einstein. And so, I don't know, again, I'm not trying to say that I have a solution, but we have to do something about the image of science that we now project to the society. If we don't do anything about this, we'll have, again, the resistance against vaccines, we'll have belief of completely absurd things, because, a journalist goes to a university, talks to somebody who claims to be a scientist and brings this information to the paper. That's it.
I mean, isn't this all related? If we have millions of scientists, then 90% of them will not be brilliant people. So, I mean, maybe this is the reason why people don't have a special large trust to scientists, because they shouldn't. You know, if we theoretically, in a theoretical world, if we fired all the 90% worst scientists in the world, hypothetically, I mean, let's say we have a godlike power to determine who is who. We just cut down everybody. We have just 10,000 scientists in the whole world, the best ones. Well, maybe then trust would be reasonable. But now we also ourselves, we are sitting here and we are saying that, you know, you can write down a simple program that will fake science, 90% of science is bad, people pretend to do science, and then we are wondering why people don't trust science, right?
Maybe also because nowadays, not only scientists, everybody, due to internet, has a chance to popularize his ideas or his papers. So maybe 100 years ago, if somebody was really a not good scientist or bad scientist, his influence for the society was very, very small. And now it should be small, but some people who should not be called scientists, they are active in social media and they can be considered as scientists, and somebody can ask them for advice, and therefore they may even spoil our image.
I don't think we have much of an image. The point is this, that it's a story from the 80s. We were in Germany on scholarships. My daughter went to kindergarten. In the kindergarten, there was a first wave of resistant vaccinations. And I never read this, but I remember this from the time Princess Diana took her sons to be vaccinated against, I think it was measles. And that finished that wave of resistance. Now, what do our celebrities do? They have blogs saying that you should eat only whatever, or you should not eat something else. You should never vaccinate your kids because something will happen. And the point is this, that if you're a beautiful woman who is well known, you have much more clout than I or any one of us will ever have. And I'm not going to blame the media, because they also made life much easier for us. When I was a young scientist, I guess I was a scientist, I would go to the library once a month for a day, and I knew everything that I had to know in my field. Now I'm retired, so I have a lot of time for reading, and I cannot keep up with what is being published. There's no way, simply. It's what you said, there are so many papers. But even the ones which are good, even the ones which are worth reading, there are too many of them now, because there are too many things going on. If you want to know in general how biomedicine is progressing, you can't manage that.
By the way, this was the conclusion of the paper that I quoted before about the average level of disruptiveness. Their conclusion was that as time goes by, specialties in science get narrower and narrower, because essentially there was this pessimistic conclusion that the low-hanging fruit was picked. So all or most of the huge inventions and discoveries were already done. So there's very little possibility today of doing something extremely disruptive in the good sense, in biology or physics or anything. And most scientists are just dealing with tiny, tiny problems that will interest very few people. And essentially, my thinking is maybe the age of the great scientists is gone. Maybe it's over, of the brilliant people who have these brilliant ideas and just change everything. I mean, how many more theories of evolution can we find? We've already found that it evolves, right? How many general relativity can we find? I mean, the computer has been invented. Can we expect a new computer to be invented that will be as disruptive as a computer has been? I mean, maybe it's over for the big science.
Okay, so I'm not so pessimistic. Of course, many great discoveries were already done, but several, I hope, are in front of us. We still do not understand. There's no complete physical theory of quantum theory and gravitation combined. Nowadays, not so many years ago, basically the new ideas of quantum information, quantum computer has been born, and now we look forward to see quantum technologies which are emerging. No, so it's not like this, that the good times of physics are over. Of course, it's very unlikely to write a very revolutionary Copernicus-like paper. Doesn't happen so often. But no, but we still hope, look, it's very strange because scientists publish 100 papers, 200 papers, and then they still publish 217 or 18 papers, and they still hope, even though all previous papers were not so revolutionary, they are eager to write another one, and they still do hope that maybe the next one will be the very best. And maybe it's good. They are still looking forward.
If I may say something, I think in some fields it's more complicated. The treatment of cancer, this doesn't sound like a revolution. There has been a revolution there because 20 years ago you had either drugs which would kill cells which were cancerous faster than other cells, or you had radiation. Currently you have a whole arsenal of things. The thing is that you don't really publish a paper saying, I have a wonderful new drug. You say you have phase 1 trial, phase 2 trial, phase 3 trial. That's not sexy, it's boring. Then you get, I listened to an absolutely incredibly good lecture by Professor Jacek Jasem from Gdańsk. He's an oncologist, a couple of days ago, and he referred to a paper with new drugs which were specific for various types of cancer, and it was so 2 pages in a journal. So the progress there, a lot of the papers that are being published are necessary, but as I said, they're totally, I mean, if you're not working on pancreatic cancer, you will not read the ones on pancreatic cancer, you'll read the ones on breast cancer or whatever else. So I think in a way I would exempt this part of science from the critique that nothing is happening, but it's difficult to call something a revolution when it takes 8 years.
But this is exactly what I meant, that the revolution is happening and our world is changing, but there are no huge heroes. I mean, the new next revolution in pancreatic cancer will be done by 1,000 people distributed in 1,000 papers. And in physics, I guess it's likely that the theory combining relativity with quantum field theory will be found by 50 people over 50
thousands
papers.
Of very, very tiny, small steps without a single hero, single author, but many, many people, reasonable people pushing our understanding a little bit forward.
So
it happens, yes.
Okay, we were supposed to be talking about the future of science. So what, are we supposed to stop dreaming of being the brilliant geniuses who change everything? We should stop teaching our students that they will be those fantastic new Einsteins and Newtons and Cricks, Watsons.
Well, I would not say they will be Einsteins or Watsons, but I still...
And Rosalind Franklins, yes.
Try to convince them. There are many open questions, and I try to explicitly mention that we understand this and this, but we do not understand that and over that, and there are many questions to be solved, and this is still a very promising field of, let's say, theoretical physics, and try to join us to help us solving interesting problems.
I teach 2 types of students. I mean, I teach students of biology, but I also teach people who are engineers and people who are humanities students. And it's different teaching. The ones who are engineers, who are not going to be in this field, what I have to teach them is to understand what can be done by modern biology and medicine for them, so what they should do, what they shouldn't. I mean, very briefly, if I teach biology students, essentially what I should teach them is what we know, what we think we know, and what we expect to learn in the future. Because otherwise, I see a very clear difference between teaching high school and teaching university. In high school, you have to let them know the facts which are there, but you don't really have to burden everyone with the problems which are unsolved.
No. Okay, so let's think 10, 20, 30 years forward. Do you think that the current model of science, the thing that we talk about now, it's sustainable, or are things going to break in some place?
I think that the authority or respect the society has for us is going down, and it will be going down if we don't change anything. So again, I'm not sure how, but this is not, keeping the model as we have it is not sustainable. I think this is going to be worse and worse, and there will be more and more journalists coming and publishing absurd theories that they got from some mad scientist somewhere. Again, it's going to get worse. That's my one sentence.
So what should we do?
Difficult question.
What about this? So we've already established that we don't need as many scientists. We could chop off, let's say, a quarter of the students. We don't need that many. So what if we hired influencers in their place? People who are, media savvy, they look good, they have long legs, they're sexy. And they would be the new scientists of the future who would repair the public image of science and...
Okay, so let me just remind you about one thing, because all of us are forgetting about the rest of the world. We're forgetting that there are two countries relatively big, China and India, that will become rich soon, and they will be producing lots of science, more than we produce. I believe that in 50 years, there will be more science coming out of China and India that's coming from the rest of the world. Why am I saying this?
I think it already is.
I can tell you, I can give you an example from my field. When I started my career in '97, we had 800 applications for our PhD program from China. Last year, we had 1. The number of papers published by Chinese researchers in my area, at the best conference there is, at that time was probably a couple. Now it's 1/3. 1/3 of all papers, the best conference in the field, is from China. So the jump is enormous, and it's going to go into other fields, of course. Chinese actually chose computer science as the most promising field. That's why they invest so much money into it. But other fields will follow.
They have already. In 2015, a letter appeared to think about how the human genome could be modified, to reflect on it, and so on. And the reason was that there were experiments going on in China which worried people in the Western countries. And moreover, sequencing DNA is something that is routinely done in very, very many labs in the world, and a lot of these labs send their DNA to be done in China because they have the best setups, they're the cheapest, and so on. They have whole factories of analyzing things.
Okay, so I just remembered something. Yes, they actually have a model. The Chinese researchers, for publishing a paper in Nature, I think, get about $100,000 prize from the university. Maybe that's the model. Pay the scientists to publish in the best journals.
Okay, so I will only add to this that concerning quantum computers, quantum communications, Chinese scientists did a lot progress in some, let's say, cases that even are best in the world. However, going back to the, let's say, polskie podwórko, so our local ground, first of all, I think we agreed that we should somehow try to contact other people also beyond academia. So first of all, let me thank you for inviting us here, for organizing such a festival. It's good at all that we have a chance to talk to other people. Maybe some of other people not working at science will listen to us, because we need, on one hand, to tell them more or less what we are doing, why our work could be useful, why it could be important. This is one thing. And try to have a contact with them, so in future, or in the cases like we discussed, the vaccinations, that on average, society will wish to talk to us, not only to, maybe not already to listen to us, but at least to have a contact with scientists, not to be afraid of scientists, to know what scientists are doing, what they are paid for.
Okay. I will use this short break to inform if anyone in the room has questions. I think there will be time to ask them, so you may start thinking about them. I think I will move around with the mic in just a couple of minutes. So if you have something on your mind, feel free, raise your hand maybe already. Or maybe this is a good time to take a short break from our little inner circle. Sir, feel free.
Well, I think that the problem of having too many scientists is the part of a general problem that we have too many of everything. We have too many journals and journalists, too many novels and novelists to read, too many musical composers and musical stuff to hear, to listen. So possibly the only thing that we have too little are the medical doctors and nurses. So the problem is there is a social problem, there's a political problem. What to do with this abundance? Jerzy Pilch, the Polish writer, once said about a politician that the problem is not that she has never been graduated from a high school. The problem is that she is literate. So the problem is that too many people are literate. Generally, the problem is how to organize the society that this abundance of people so what to do with this abundance of people so that they do not use too much resources and do not go for doing crimes from boredom. So that is the problem.
So, a short comment, if I may?
Sure.
I like your statement concerning abundance, and I realize I'm a member of the editorial board of Acta Physica Polonica B, so one of the, not so many journals in physics in Poland. And in short, we have abundance of bad papers submitted and not enough of good papers submitted. And I think in general, this is the problem. We might have too many not good enough students and not enough very good students. And also too many, let's say, postdocs which are not good enough, and not enough very good postdocs which are brilliant.
Okay, sorry, let me ask you. Let's say you have too many bad papers. How many papers is published in this journal, and how many of these are good ones in your metrics?
Delicate question. So, okay, the order of magnitude, I would say, would be like 100 order of magnitude, not 10, not 1,000 papers published, let's say 300 papers received, and then let's say half of them are really not good one. So half of them are, I guess, should be being.
Yes. Well, sort of the follow-up was maybe we don't need a journal.
Okay, wow, this is a delicate story. No, of course.
I know it's a brutal question, but I mean...
Sure. Okay, look.
About the postdocs, right? You have too many bad postdocs. Maybe the position is not needed.
It's needed.
I know we are talking about good universities here, right?
No, it's needed. I think, how should I put it? If you have a graduate student, undergraduates, if you're lucky, they can do nice things, but most of them spend their 2 years learning things. Most of them, in my field, do not get a lot done. Graduate students are, if they're continuing what they started, if they're new, it takes a year before they get productive. Generally, postdocs are people who have already mastered a number of techniques, who know how to get, how should I put it? It's a bit like languages. If you know 5, the 6th one is not too much of a problem. But the first 4 in one could be, unless there are special circumstances. Postdocs are people who are able to learn much faster than people in earlier stages of the career. The problem is, though, it's not a question of too many. It's a question now in my field. I see advertisements for postdocs. I have a grant, I want a postdoc. I have a grant, I want a postdoc. And you don't get them, because if they're really good, they will go somewhere else.
Mm-hmm. So one more remark to just defend our journal. As you mentioned, this distribution of citations is skewed, and perhaps of the quality of papers very skewed. So the fact that we have like 1/3 of papers which are reasonable, and perhaps 1/10 of those would be really at a very high quality, I already consider it as a great success. If there are several papers there where a few of them got 10, maybe 20, maybe 30 citations, we are already happy with it. Moreover, this is a Polish journal created more than 100 years ago. And of course, my colleagues, my students, they prefer to publish elsewhere. But it's good to have at least 1 or 2 journals in Poland in this field. And then it has also important, let's say, social role. every year, for instance, another journal in Toruń, on mathematical physics, they organize symposia of meeting of the editorial board. It's a good excuse of very high quality scientists to come to Toruń, come to Poland. We meet there, we have meetings. So such a journal, it is of great value. Or could be.
I disagree completely. I mean, I was on the board of two journals. I've gotten rid of one. I will get rid of the other. One of them is for reviews, and most of the reviews, even in my field, are much too long and not worth reading and take a long time to publish. It's better to read them in English. The other one is complicated. It does have a reasonable impact factor, but how should I put it? As you said, a lot of the papers that come are really quite horrible. So it shouldn't be. Yeah, but I don't get beautiful red and white flags waving in front of me when one says a Polish journal. I think if it disappeared, I wouldn't mind.
Would it also be true about some universities?
This is much more difficult because I think someone once convinced me that you should not only have universities in big cities simply because of the cost of studying, not in the sense of paying for the studies, but the cost of maintaining a student, say in Warsaw or in Krakow, for a family from a village in the middle of nowhere. So I don't know, perhaps the lower level of study, say the first 3 years, I would be more, I think we have too many anyway. In Warsaw, I think there are the 5th medical schools, universities is being initiated. Actually, at the University of Warsaw, I have no idea where we will get so many medical students. But going back to your question, because I sort of deviated, it is a social problem more than a scientific one.
Okay, the subject of scientific journals came up, so let me change the topic. Let's leave the problem of whether we have too many scientists or not. It's a tricky one, but let's go to something else. The current model of scientific publishing, there is a lot of bad press about it. I think about a month or 2 ago there was a scandal, if I may say so. The whole editorial team of a large journal in the field of biology resigned. I think it was an Elsevier journal, if I'm not mistaken. So one of the world's largest publisher of scientific papers, Elsevier, lost its whole team because they protested against the current policy of publishing, the current financial policies of publishing. So what do you think about all this? And where are we heading? Is it possible that all science will be openly, freely published?
So actually, I did some research a while ago. I actually wrote a popular paper on publishing as such. So a bit of data, because probably many people don't know it. European universities, libraries, spent in 2017 was the last data I remember, spent over 500 million euros for the privilege, for licenses to publish, to have the papers of the commercial publishers in the libraries. They have to pay it. But here's the point. Scientists have been tired for a long time having to publish, to use the commercial publishing houses to have their journals there. I'm not sure why they don't take matters in their hands. In computer science in North America, we have Association for Computing Machinery and some other organizations that have complete control over the journals in which we publish. Why can't scientists in other areas do the same? Why is it so hard? Why do we have to use commercial? Of course, if we use Elsevier, Springer, all these guys, they have to make money. I think this is one of the reasons why Synthese publishes 500 papers, because more papers, remember, more papers, then the more money they make on people who actually buy it online. Each paper costs about 20 or 30 bucks, so you have to actually spend. More papers you have, more money you're gonna make. Their goal is entirely different from our goal. Our goal is to have high quality papers published. Their goal is to have more papers published.
And more money.
And more money, yes. So why don't we, because I am actually in a good camp, I already have my publishing houses, our own, our commercial, our professional organizations. I don't understand it, to be honest.
I think for a young scientist, there is the option of submitting the paper to, Nature Neuroscience and being published in a very, very famous brand, or trying to cooperate with a new place which maybe nobody reads, nobody heard about. I mean, the most famous journals are the ones that are paid for, right? So maybe that's the reason.
Yes, but it is not so bad, let's say, in my field, in theoretical physics. I mean, there are prestigious journals which are not owned by Springer nor Elsevier, but just by, let's say, American Physical Society, or it's called Institute of Physics in UK, or Polskie Towarzystwo Fizyczne, PTF, which is not as prestigious, unfortunately. And then, of course, you have to pay something, but much less than you pay Elsevier and Springer. And nowadays, in my subfield, it's really a habit to submit usually there to those journals which are owned by societies, professional societies, and not by commercial companies.
I think my field is a mess, to the best of my knowledge, because there are very, very many papers, and we had a discussion online about 2 months ago what is and what is not a predatory journal, because some were saying this one was and others were saying it wasn't. I have no idea, I haven't published there, so it's difficult. There are a lot of them. The thing is now that most European grants demand that the results financed by Europe must be published in open access journals.
Yeah, I mean, I have just been in the situation of having to pick a journal, and it was a biological paper, by the way, and it was a review paper, so I'm not going to say anything more for fear of being discovered, but essentially a Polish scientist who wants to publish a paper, is confronted with this huge table with points. I don't know, maybe there are people in the room who don't know the system, but there is these magical points. And
of Polish minister, yes?
Right?
Of Polish minister, you mean Polish points?
Yes, of course.
Sure.
The famous Polish points. Yeah. Yes. So it's like a computer game. You have to get as many points as possible, and there's a little ding when you get a lot of points. So my job as a good scientist hired by a university is to give my university as many points as possible, right? That's my job, to bring points to the table. So I have a list of journals, and I sort them by points, and I submit them by number of points. This is my algorithm for publishing. So I chose a journal that has 200 points, and all of the journals that have 200 points are owned by Springer. It just so happens. Yes. So for a scientist, it's a very, very simple procedure. If I want to be a good scientist, I have to bring a lot of points to the table, so we have to pay.
I understand what you mean, of course, but I think it's kind of over-exaggeration. I hope I'm kind of more resistant to this fever of ministry points of Polish minister. Basically, they change from time to time. So my, let's say, utility function is not only to optimize the number of points. I prefer to publish in really prestigious journals, even though minister last year allotted not 200, but let's say 160 or even 120 points. I don't care so much, provided it's really a good journal. Yes, so basically my reasoning or my estimation is not exactly similar to those of our minister.
But if I may something, there is an age difference between the two of you. And that is that.
And the location at the career path. I mean, I think you can do it because you are at a certain point in your career where you can tell people that it's a good journal and they will believe you, and tell people it's a good paper and they will believe you. I'm a relatively young researcher.
Yeah, sorry. But of course there is a huge correlation.
Nobody will listen to me if I say, I have a fantastic paper, but you know, this journal, it's not even on the lists. I mean, it's okay, it's 40 points. Nobody will even listen to me.
I agree, I totally agree. I only mentioned a minor differences. It's not like this that I prefer to publish in not prestigious journals. No, but sometimes I think I'm convinced enough that this is a very good journal, even though by chance or by something minister this time has not gave it 200 by, let's say, 120 or whatever. And then publishing two such articles a year, we get score whatever 240 points, which more or less compensates one journal in Elsevier. So just to finish this sentence, we are not feeling like slaves of commercial companies like Elsevier or Springer.
Just want to add, this is bizarre what's happening in Poland, so let's not talk about this.
Also, one
Why
thing,
not?
I mean, I do a lot of evaluating of things, and don't tell the ministry, I never look at ministerial points when I evaluate. I look at journals, citations, impact factors, and both things are important. I mean, sometimes you have very high impact things which are never, ever, ever cited, and sometimes you have, say, reasonably low impact journals where a paper appeared for whatever reason. I have a friend who is, well, he's a member of the Academy of Sciences, quite famous person. He says that his best paper and best cited paper appeared in a poor journal because 5 other journals had rejected it and he had to finally publish it. So that also happens. I mean, it's an exception. But remember that at the beginning I said that Europe is trying to think of a system of evaluating the science and not sort of just numerical things. I don't know how this could be done, but this is needed, because if you just add up the impact, I mean, there's something called the Hirsch index in the sciences, which is how many times, how many of your papers were quoted. So if your Hirsch is 30 of your papers were quoted at least 30 times. And this is also a measure of something, but sometimes it's just a measure of age.
Okay, no, but just one more remark. I totally agree with this point. Sometimes also we look at the editorial board to see if it's a serious journal or not. And then somehow knowing the field, it tells us sometimes more than the official points from the list of ministers. So I also managed to survive several years not looking how this list has changed. Sometimes it changes in a reasonable way, sometimes not. But we can afford such a luxury not to look there too often.
A short anecdote about these numbers and these citations. I was, I think a week or two ago at one of Poland's universities, and there was this bunch of statistics about how well the university is doing and which area of study was the best at this very university. And they used this automatic method of finding which area of study has the most citations. And it was discovered that biology is the best area of study at this very university.
Which one?
Biology, one of the universities. And I asked the guy who prepared the report for his data, which were these fantastic papers. And there was this just one paper, changed everything. It was quoted 600 times. And it was a paper where a new species of fish was determined. And all the other ichthyologists had to quote the paper, because if you describe a new genus or a new family or a new species, all the other scientists quoted. So there was this amazingly quoted paper, which I later found the author of the paper, and they said it's just a normal paper. But it was like a peak in the statistics, because it was amazingly quoted for a very obscure reason in how biology works. And we had this talk about how crazy it is that you decide on the quality of the science done at a university.
Okay, but one more remark. So to interrupt you, but such a single paper will not change this age index of the institute so much. It will contribute by single number 1. So it will not change the total image.
The Hirsch index not. It wouldn't change the Hirsch index,
exactly.
but it was a different measure.
So this is one argument that this Hirsch index H has some advantages. I don't claim it's the best measure, whatever, but it is, in a sense, a little bit more reliable than, for instance, the total number of citations scored by all employees of the entire institute, faculty, or university.
Okay.
I would agree with that, because I mean, you can have tons of published things, and as someone mentioned, 90% of them will never be read by anybody. So that it is another measure. But how to evaluate whether science is really good science is not to be done by shuffling numbers.
I think I remember when I was just a student, there was this move from qualitative evaluation to quantitative evaluation. The argument then was that right now, it was the 1990s, I think, right now at the universities, there is this class of friends who, you know, rate their friends' work great, and they just say, yeah, this guy is a fantastic scientist, and there is no measure to determine who is a good scientist or not. So it all ends up in this big boys club of people who just tap each other's back, pat each other's back and say, yeah, you're a great scientist. And back then, I remember there was this general understanding that, now we will have numbers, and the numbers will save the Polish academia, because we will not be led into hands of some experts who will just, praise their friends' work, but the numbers will be the solution to the problem. So now we have numbers. So let's say we want to go back to expert opinion.
Not just. I mean, we have changed a lot. I mean, I remember the initial funding, which was small, was done exactly as you say. Professor A reviewed Professor B's papers, who reviewed Professor C's papers, who reviewed Professor A's papers, and everyone was a great guy. But the money was small. Then we got Komitet Badań Naukowych, where it was better. Now you cannot have, not located not that far from here, the Narodowe Centrum Nauki, National Science Center, you cannot review papers within Poland except the one very small one, the miniaturas. Everything is sent abroad. Even if you have someone from Poland who publishes in PNAS, Nature, or whatever, he cannot review it. So we've gone to the opposite direction. For me, I mean, I have been reviewing things for years and years. It's difficult. If it's my field, I can evaluate the science. If it's a little away from my field, I can evaluate the science. If it's something where I can understand the impact factors and the papers and the citations, and I cannot evaluate the science, I probably shouldn't be evaluating it. But in any case, sometimes it does happen that you have to look at something that is a bit way off. And the numerical things are a guideline. If you take them as a guideline, it's okay. If you take them as the finished version of how you should do that, if someone has, I don't know, 101 citations, someone else has 99, the 101 must get the grant and the 99 mustn't, it's stupid. It doesn't work that way.
So let me just, I understand completely the motivation that went into inventing this point system in Poland in the 90s, but it just got to the point where it actually should be abolished, I think, because now, as you said rightly, the papers should be, and their authors should be reviewed by international scientists. That's what we had in Canada forever. There is no border in terms of science with the US. So when I went up for tenure, more than half of the reviewers of my case were from the US. When I go for a grant renewal, standard grant that we get in Canada in sciences, the panel that evaluates me contains about half Americans, smaller part of Canadians, and some Europeans. And of course you have to have money for it, because these people are invited and flown over from different countries just to meet and evaluate my application. So, but once you have this, nobody pays attention to any points. It's expert opinion only, and these people are extremely fair. I've actually took part in these evaluations a couple of times, and I was incredibly impressed how well and how just and fair they evaluate the cases. You don't need points. That's what it is.
One more remark. I agree that nowadays in Polish we say punktomania, so we are obsessed by points, ministry points or others, it's bad. However, 20 years ago, it was good, especially for those groups, there were some scientists who were not working hard enough. They realized, because of the number of points, they were summing zeros many times, the result was zero. So basically, points were used and helped them to realize they are not working fine. Moreover, points sometimes can be helpful, provided they are used in a reasonable way. So nowadays, of course, we should not overestimate the meaning of numbers and points, but it should be combined with the standard peer review. But we should not, let's say that points and, let's say, number of quotations and Hirsch index is not relevant at all. Only we should use those numbers in a reasonable way.
Okay, I think moving on, we've talked quite a lot about the nitty-gritty of science. Let's do some science fiction. Do you think that in a reasonable amount of time, the input of non-humans into science will be, let's say, considerable?
In my
the
field,
input of
not.
ideas of artificial,
Yes,
the,
so in
the,
my
the
field, I
influence
hope
of
not.
artificial intelligence into the actual intellectual part of science. Not about writing the papers, about the actual intellectual innovation in science.
I could give you two examples. One is from
So you say yes, it will.
not, but I'll tell you in which field. Not in computer science, of course. So, two examples. One is very recent. The company that designed AlphaGo, that's the system that won the game of Go with the great master from Korea, I think. They actually created a version of it called AlphaFold. I know you can probably help me with this. This system was able to, I have no idea what it means, do the protein folding. So explain.
If you have a protein, the sequence, how the amino acids are in line is easy. How the protein is structured is difficult.
Yes.
There are some data you can get from crystallography, but some you cannot. Not everything crystallizes. And this program can do it because somehow it manages to, foresee the structure of any protein now.
So just to give you the context in numbers, the number of these protein foldings that people invented so far was about 200,000. This system came up with 200 million in a matter of days. So you can see the enormous difference. Not all of this is correct. The humans have to verify it, but it's still a big jump forward. But there's another case from a few years ago, which was because this is actually, this is done by a completely automated system. And in, I think 5 years ago at MIT, they had a lab that tries to help biologists and people working in medicine to solve their problems. And one of the problems that people have is inventing new antibiotics. This is difficult because we pretty much, from what I understand, again, correct me if I'm wrong, for the last 30 years, there has been no new antibiotic of a different kind invented. And the ones that we have created resistance in bacteria. And so we have a problem. And so how do we invent antibiotics? First of all, we have to know that the given chemical compound is possibly an antibiotic that satisfies certain conditions that antibiotics have to satisfy. And so at MIT, they came up with an AI system that they actually trained on known antibiotics. That system learned the features that these compounds have, and then they fed it with completely new compounds that they haven't tested yet. There was tons of them because humans don't have the time to verify every single compound they can come up with this. There was one that was generated artificially, a chemical compound, by a relatively unknown company for the treatment of diabetes. It turned out it wasn't very useful, didn't work well, so they just put it aside and forgot about this. They actually fed this into this system, AI system, and it came out bingo. It actually seems to be antibiotic. So this is the test called, I think, in silico. Then there's a test in vivo. In vivo is the last one. In vitro is the second one. They tested it further, and turns out this is the first, again, in many, many years, completely novel antibiotic that actually kills the bacteria that no other can. It's called halicin, for obvious reasons. I'm not going to tell you why the name halicin. But it's actually, this is the discovery of lifetime, I think, because if computer science, this is computer science job. This was not, biologists were not involved. The biologists gave us data, not us, it wasn't me, it was MIT. Gave them data, and they used the data to come up with this. It will be more things like that. I'm pretty sure that it will help scientists to basically sift through the enormous possible options that they have in their science domains to narrow down and then have the humans as the last step in verifying that what the system found was actually useful. So I'm very optimistic in that sense.
I have two more examples. One is very medical. The AI helps pathologists to sift through X-rays and other types of photos so they can focus. I mean, instead of getting 300 to look through, they get the 20 selected ones that the trained system finds should be analyzed. And the other one is something that, in a way, has really become, well, maybe a revolution is the wrong word, but when the Human Genome Project started, the idea was it would be lovely to have one letter of the genetic code cost $1. Would you give like 3 times 10 to the 9th for one genome, and you have to do it many times. And the things that change this, the cost is now a couple of $100 for the whole genome, is technical things in the sequencing, but perhaps even more so computers and analysis. Simply, just as a one example, a friend of mine had his genome sequenced, but he's also a specialist in these things, so he redid it by himself. It took 1 month of a strong computer a couple of years ago to calculate it. So now this is also progressing, and these were things that could never be done by hand. You do not go through 3 times 10 to the 9th of anything by hand. It's not doable.
I'm going to interrupt you because you are ungrateful. You said that it's not going to work in your field. How about CERN?
Okay, so I just want to make a short comment about it. So, of course, I do agree, and there are already several examples like this. Like you mentioned, Go, a very nice game that not only won with Grandmaster, but found some new strategies which were not known before. This is true. Moreover, using good computers, artificial intelligence, we can find, let's say, new constellations in the combinatorics, new constellations of quantum states I work on, and so on and so on. But there are minor issues. If you already solve the problem for, let's say, small number of particles or in small dimensions, then artificial intelligence can, in a sense, extend known solutions or find new solutions, but it is not going beyond the theory. It will not, what I was thinking about, artificial intelligence, in my opinion, will not create new physical theory, will not help us to understand, to really change, to get a breakthrough in our understanding of the nature. And of course, will be useful for thousands of many relatively minor achievements which push forward our understanding of the field.
But again, if without computing power you have at CERN, you would not be able to analyze the data.
Sure, okay, of course. You can say that, as we know perhaps very well, even our internet and www would not be born if it were not created at CERN, only because physicists are lazy and they didn't want to go to the second room to check the data produced by their colleagues, so they want to create a platform to join computers, so they were not forced to move to another building.
But if I may, I mean, the examples are great. I'm a big fan of all this, but somebody could say, and I'm going to be the one to say it, I mean, there were algorithms to predict protein structure before. They were worse. Now we have a better one. Okay, but this is not a new idea, right? And what I was asking about, maybe the antibiotic. Okay, but there were also before certain methods of checking if something is an antibiotic or not. This is still, I'm not satisfied. This is not new ideas.
Yeah, so this is exactly my
I'm
point.
sorry,
This
you said you believe that there will be no new fundamental breakthroughs done by artificial intelligence.
I hardly believe they will come soon. Okay.
So sorry, my question was, okay, so here is this thing that AI can do better, something that we have already done by certain algorithms, but it's non-exciting to a general audience. And here we have Copernicus, Newton, Einstein level breakthroughs in science. Where do you think AI can go? How far?
Remember that the biggest discovery of the last few months is the ChatGPT. I remember how it works, you know very well. It's just adds words to sequences of words, and it learns from the stuff that is available freely on the web, and so it learns from what's already available. That you can't generate something extraordinary out of the stuff, out of text that you get on the internet.
I'm sorry, but Einstein did it. I mean, his brain worked on information.
But he wasn't working the same way that this opened.
So what's the difference? I mean,
I have no idea. Don't ask me.
Yeah, but I mean, he actually did invent whatever he invented based on available information, right?
But can an AI do it with something?
Well, this
we
is
cannot?
exactly my question.
No,
but I just
we don't
dispute
know.
the counter-argument that that's the difference. I mean, of course, ChatGPT is working on the corpus of information given to him, just like every brain in the universe does. All minds work on available information. So that's not a difference. Right?
The question is a little bit of the way science develops. I mean, we sort of look at it in a linear way, but we're also talking about revolutions. I have no idea whether a computer can jump. A human mind can. It has been shown to do it in those few cases that were real breakthroughs. But whether I don't understand how a computer works, so I don't understand what it can do.
You know, you're a philosopher, so you know how scientific theories are organized. So a scientific theory sits above the data. You cannot infer the theory from the data. You can infer the data from the theory. You can predict certain phenomena happening. So it's always more than the data contains. The theory is always more than what you can get out of the data.
Okay.
So it somehow takes a great mind to come up with a theory that explains the data. And I don't see how ChatGPT could do that. Because it can only infer it from the data.
But this is exactly my point. So ChatGPT, or like good chess computer, has a lot of data, a lot of chess games, and therefore is a very strong opponent to basically hardly any human can compete, because brute force of computer plus enormous amount of data is good enough to kill all of us. However, this does not mean that artificial intelligence will be, clever enough to really get some revolutionary breakthrough ideas. This is still unlikely, in my opinion.
Okay. I'm afraid we don't have time to continue because it's 9 past and we're supposed to end 10 past. I think we may continue in the hallways of this beautiful building. And unfortunately, there's also no space, at least officially, for questions. But I guess that the world doesn't end at this moment. So I officially end today's debate. Thank you for present. Thank you for being here. And have a good evening. Thank you.